Hello everyone, in this unit we will discuss the topic of integral. Integral or integration is also known as antiderivatives. It's the reverse process of differentiation. Like if you have a function fx, when you differentiate it, you get f dash of x. Now if you want to return back to the original function, what you need to do? You need to do the process of integration. Okay, so when you differentiate a function f of x, you get the derivative of the function f of x. Now if you want to return back to the original function, you have to use the concept of integration. That's the reason it is also known as antiderivatives. Okay, so the formulas are basically you can get it from the formulas of derivatives. Like if you remember the formulas of derivatives, it is easier for you to get the formulas for integration. For example, we know that the derivative of sine x is cosine of x. So when we talk about integration, we'll have the formula as integral of cosine x dx as sine of x plus c. We add the constant of integration because here we are talking about the indefinite integral. Indefinite integral. We will talk about it later, like the kinds of integral that we have in other video. Okay, so we were having originally function sine of x, which we differentiated to get cos of x. Now if we want to return back to the original function, what we will do? We integrate the function cos x, that gives us the function sine x. Okay, similarly we know that the derivative of cosine of x, you studied it like derivative of cosine x is minus sine x, so we can move the minus sign on the left side. So this gives you integration of sine x dx as minus cosine x. Remember here the sign gets changed. Similarly, as derivative of tan x is secant square x, the integration of secant square x is nothing but the tan x. Okay, and in this way we have all the formulas. We do have it for the power rule, as we know that the derivative of x power n is x to the power n x power n minus 1. Now if we differentiate this term, x power n plus 1, what it will give you? N plus 1 x to the power n plus 1 minus 1, which is nothing but x power n, and this n power n plus 1 get cancelled with this. That led you to the term x power n. Hence you can say integral of x power n dx is x power n plus 1 over n plus 1 plus c. So this is written in modified form. Okay, note that this formula is true for all values of n except n is equal to minus 1, because when n become minus 1, what will happen? Integral of x minus 1 x to the power minus 1 dx, if we apply the rule, gives you minus 1 plus 1 minus 1 plus 1, and this term is nothing but 0. So this becomes not infinite. Okay, so this function is not defined. So that's the reason we say that this rule is applicable for all values of n except n is equal to minus 1. Now what will happen when n is minus 1? When n is minus 1, we have the rule x to the power minus 1. We can rewrite it as 1 over x dx. So this is nothing but natural log of x plus c. So this is another rule when n is equal to minus 1. Now what will happen if n is 0? If n is 0, we have integral of x power 0 dx, and we know that any number power 0 is 1. So integral of 1 dx, there is no x term, so it is nothing but x plus c, the constant of integration. Now how this rule comes? Because we know that derivative of x is 1. So that's why integral of 1 dx is x plus c. Okay. Similarly, if we want to see how this rule works for different value of n, let's see it over here. Like suppose if we need to find integral of x power 3 dx. So in this case n is 3. By the rule it is x to the power 3 plus 1 over 3 plus 1 plus c. So it is x power 4 over 4 plus c. This will work even for the rational powers of x, like suppose if we have x to the power 5 over 2 dx. Still we can use this rule because the only restriction for the value of n is n should not be minus 1. Okay, so this gives you x to the power 5 over 2 plus 1 over 5 over 2 plus 1, that is 2.5 plus 1 plus c. You can use calculator for that. Means if you want to put it in decimal form. Otherwise it will be c 7 over 2 and 7 over 2 plus c. And to make this more simplified, better to write it 2 over 7 x to the power 7 over 2 plus c. Okay, now what other kind of examples you can solve based on this rule is, like suppose instead of just one x you have say x to the power 2 over x power say 5 dx. So now here you have powers of x and it is in division. So in the integration what you will do, you instead of using this rule directly, you first merge them together if possible and make a one term. So here we use the law of exponent, which says that x power a over x power b, it is x power a minus b. In some questions you may use x power a times x power b as x power a plus b, because the base is same, the powers get added or subtracted depending upon its multiplication or division respectively. So here when we apply this, it will become integral of x to the power 2 minus 5 dx. So this gives you x to the power minus 3 dx. Now in this case n is minus 3. Again it is not minus 1. So yes, you can apply the rule that gives you the value x to the power minus 3 plus 1 over minus 3 plus 1 plus c. That is x to the power minus 2 over minus 2 plus c. So this will be the integral. Okay. Similarly, we have rule for exponential function. What that rule says? That rule says that integral of e power x dx is same, e power x plus the constant